To determine the concave direction of a function, you need to analyze the sign of its second derivative at that point. Here are the steps to explain the process. Step 1. Find the first and second derivatives of the function, f, x. Step 2. Set the second derivative equal to 0 and find potential points of inflection, where the concavity might change. These points are candidates for points of inflection. Step 3. Take test points from both sides of the potential points of inflection and plug them into the second derivative to determine its sign. If the second derivative is positive in an interval, the function is concave upward. If the second derivative is negative in an interval, the function is concave downward. Point of inflection refers to the point on the graph where the curve changes from being concave upward to concave downward or vice versa. The change in the shape of the curve is what characterizes a point of inflection. Let's look at an example. If we take the second derivative of f, x, and obtain f, x, equals x, we find that the second derivative is 0 at x equals 0. Using test points on both sides of x equals 0, we find that the sign of the second derivative changes from negative to positive. Thus, x equals 0 is a point of inflection. The properties of the second derivative indicate whether the original function f, x, has a concave downward or concave upward curve. Especially, at the points where the sign of the second derivative changes from negative to positive or from positive to negative while the second derivative is equal to 0, the curve of the original function changes, and these points are called points of inflection. However, just because the second derivative is equal to 0 at a point, it doesn't necessarily mean that the point is a point of inflection. For it to be a point of inflection, the sign of the second derivative must change around that point. If the sign of the second derivative remains positive right pointing arrow 0 right pointing arrow positive or negative right pointing arrow 0 right pointing arrow negative, then the curve of the original function will also exhibit a shape that is concave downward, then momentarily flat, and then concave downward again. Therefore, in such cases, it cannot be a point of inflection.